let's talk about integral techniques. There are a couple of integral techniques, and we will focus on the so-called u-substitution. In Calc 2, you also learned how to do integration by parts. But I will leave this for yourself because I will try to avoid integrals that requires the technique using integration by parts. So we'll mainly focus on u-substitution. Okay, so that's what we're gonna do. Okay, so when do we use u-substitution? So it's when you recognize there is a composite function. Okay, so let's practice a little bit. For example, if I'm seeing f of x is equal to sine of 2x, is this a composite function? Yes, because the outer function is a sine function, okay, and the inner function is a 2x. Okay, so when you now do g of h of x, you get sine of h of x, which is sine of 2x. Okay, all right, but we can write this in a more organized way. You can say y equals f of u, which is sine of u. And then you can say u is equal to g of x, which is 2x. Okay, now this way you would still have y equals f of u. And what is u? U is nothing but g of x, which is a 2x. Okay, so with this notation, we can write things in a more organized way. So when we observe a composite function in our integral, what we can do is try to recognize the outer function and inner function. All right, so here we have inner function being, I'll try to skip this, being 2x. Okay, and we just follow the following structures. So let me give you a more general formula. Okay, so we observe an inner function, and from our observation, this particular one is equal to 2x. So you start with this, all right, and then you look at the differential. So you write du equal to, now this is straightforward computation. Du equals g prime of x dx. So it's always this. It's always this. of course, this depends on your variable. If you have g of y, then you have g prime of y dy. Because we're using x here, so we have g prime x dx. Okay, so write this out. That's 2 times dx. Okay, derivative 2x is equal to 2. Okay, so now we have a very neat equation. This is important. Okay, all right. U equal to 2x. This is also important. So what we're gonna do next is we're gonna write the original integral in terms of u. Okay, so now sine of 2x becomes sine of u. What happens to dx? Du equals 2 dx. So what does that say? That says dx is equal to 1/2 du. So 1/2 du, you can pull the constant out. All right, so now you can apply the basic integral formula, and then you have 1/2 negative cosine u plus c. Okay, but in the end, don't forget that you need to write the u back to x. So this is cosine of 2x plus c.